Rainbow formation, it's so easy. Three phenomena: refraction, dispersion, and total internal reflection. Wrong! That's the biggest mistake many students do. That's why we are here to learn dispersion of light and rainbow formation in a nice and simple manner in just one video. Welcome to Concept Bites. So, everybody, let's learn what is dispersion of light, how rainbows formed, and for that, let's start with something which is very magical. A rainbow. Yes, rainbows are so good. Whenever you go out, it's a rainy day, and suddenly you see a rainbow. दिल खुश हो जाता है ना? हम लोगों को बोलते हैं, यार आज मैंने इंद्रधनुष देखा, आज मैंने रेनबो देखा, right? But question is, from where does the rainbow get its colors? Yes, it's colorful. You're right. But कहाँ से आते हैं ये कलर? ध्यान से सोचो. हाँ? What do we have in the sky which is constituting these colors, right? It's a very simple question but very important question. We'll answer this. अब ये है कहानी रेनबो की. इस कहानी में एंट्री होनी है अब हीरो की, right? The hero is Prism. Let's see what is a prism. Listen to me very carefully. Prism is nothing. It's just it's a polyhedron, but in very simple words you can say it's a triangular shape, or it's a three-dimensional triangular shape. Something which looks like this. Now, notice, क्या है ये? एक base है और दो triangles हैं which are kind of making this shape, right? Nice. Now, refraction of light by a prism. If you notice, light ray starts from there, right? Light ray starts from here, it bends like this, and then it bends like this again. So in very simple words, we can say कि यार prism के अंदर light ray हमेशा base की तरफ bend कर रही है, right? If light ray is going, if you notice, it is again and again bending towards the base of the prism, है ना? Okay. ये शायद अभी आपको नया लग रहा होगा. You might feel it's something new, but you know what? If you know the basics, it's nothing new. Let me prove this to you. Why it's not something which is new. Listen, when light ray is going from here to here, this is the first interface, right? This is the interface where we have air and let's say glass. Let's say prism is made up of glass. Light is going from air to glass. It's going from rarer to denser medium. It will bend towards the normal, right? Okay. On this interface, this is our normal, and the light ray is bending towards the normal. You can say it is bending towards the base of the prism, right? But from the basis of the refraction, we know what's happening. Then light travels inside the glass, travels, glass. Haan, okay. Then it reaches this particular point. Again, there is an interface. From glass, the light ray has to come out in air. From a denser medium to a rarer medium, light ray will bend away from normal. This is my normal, and light ray is going to bend away from normal. As simple as that. हमको क्या दिख रहा है? Sir, base की तरफ मुड़ गया. ना, refraction हुआ है with the same basic laws, right? So that's why. What do we see? The light ray is bending towards the base. Now listen to me. If this prism was not there, imagine this prism was not there. What would have happened with the light? अगर prism नहीं होता तो light ray का क्या होता? कुछ नहीं सर, light ray मस्त सीधे निकल जाती. एक तो मेरी drawing भी खराब है. Light ray would have gone straight like this if there was no prism. Agree? Yes or no? Come on. Agreed? Very good. But finally, where do you see the light ray? Let me draw it with some other color for you, just for the sake of understanding. Color change अभी कुछ नहीं हो रहा. Light ray finally जा रही है ऐसे. यार, light ray should have gone like this, but because of prism, the light ray is finally going like this. ये जो difference है ना, right? What is this? This is an angular difference, right? This is a deviation, but it's an angular deviation. Light ray ऐसे के बजाय ऐसे turn हो गई, right? The light ray would have gone like this, but now it has turned with this much angle. It has deviated by this angle. This angle is called as the angle of deviation. मुश्किल है? नहीं है, right? So this angle, the angle between incident light and the emergent ray, this is the angle of deviation. क्यों? बिना prism के light जाती है ऐसे, finally वो जा रही है ऐसे, तो ये जो angle है ना, ये angle, this is the angle of deviation. Very simple. अब basic term सुन लो. Angle of prism. ये दो चोटियों के बीच में जो angle है, this angle is called as the angle of prism. Angle of emergence, we all know, it is wherever light ray is coming out finally. वहां पर जो एंगल होगा उसको बोलते हैं एंगल ऑफ इमर्जेंस। सेम चीज तो वहां भी था रिफ्रैक्शन थ्रू अ ग्लास स्लैब में, है ना। एंगल ऑफ डेविएशन आई जस्ट टोल्ड यू, एंड रिफ्रैक्टिव इंडेक्स ऑफ प्रिज्म इज n, and it's of glass, then you would know it's 1.5, right? ठीक है, very good. This is clear? Now, if you notice, this laser was of red color. Yes. Okay. What if we change the color? That's another very important point from exam perspective. Listen to me very carefully. Deviation of light through a glass prism. Angle of deviation किस पे depend करता है? First is it increases with the decrease in wavelength of light. अगर light का wavelength decrease करेगा, the angle of deviation will increase. I'll explain you. First of all, listen to me. And angle of deviation will increase with the increase in refractive index. अब इसको समझते हैं, सुनो ध्यान से. What do you see? We have two lights, right? है ना? We can say this one is, let's say, blue, and that one is, let's say, red. Fine. Red is bending less. Yes or no? Red is bending less. Red इतना bend हुआ, blue इतना bend हो गया, right? Whichever will bend more will come out from the bottom. नीचे से कौन आएगा जो ज्यादा बेंड करेगा, राइट? ठीक है. सो रेड इज बेंडिंग लेस एंड ब्लू इज बेंडिंग मोर. फाइन. रेड का वेवलेंथ और ब्लू का वेवलेंथ में क्या डिफरेंस है? व्हाट आर द डिफरेंस बिटवीन द वेवलेंथ्स? यस, दैट्स एन इंपॉर्टेंट पॉइंट. वेवलेंथ, WIBGYOR, WIBGYOR, WIBGYOR. As you go from violet to red, wavelength increases. Wavelength क्या होता है भाई? Light, in very simple words, we can say light is like electromagnetic wave. एक sine wave की तरह से. The distance between two crests is called as wavelength. बहुत सही. अच्छा, wavelength multiplied by frequency is equal to speed of light. Very good. यानी कि what does it mean? If wavelength is more, by speed of light is a constant, right? This is a constant. अब if lambda is less, means if wavelength is less, frequency will be more. If lambda is more, which means if wavelength is greater, frequency will be less. सच बात है ना? Clear? Okay. So as you go from violet to red, the wavelength increases. Very good. Speed of light. Speed of light. Come on. Speed of light. Speed of light. You saw that red is bending less. Why does a light ray bends? A light ray bends because its speed decreases. जिसका speed ज़्यादा decrease होगा वो ज़्यादा bend करेगा, right? Now red is bending less, so speed of red will be maximum in refraction. This too we have learned, right? Speed of red will be maximum out of WIBGYOR, by the way. Speed of red will be maximum and speed of violet will be minimum. क्यों? सर red ज़्यादा bend नहीं करता है. Red bends the least means speed will be maximum. Violet bends the most. इस पे सबसे ज़्यादा effect पड़ा, right? Violet bends the most means the decrease in the speed of violet will be the most. Clear? All right. So violet is also fine. What about refractive index? जो ज़्यादा bend करता है उसका refractive ज़्यादा होता है. Simple सी बात है. Whoever bends more मतलब उस पे ज्यादा ऑप्टिकली डेंसर मीडियम का फर्क पड़ा. सो मीडियम इज डेंसर फॉर दैट पर्टिकुलर वेवलेंथ. सो यू कैन से फॉर वॉयलेट से ज्यादा बेंड करता है, इसका रिफ्रैक्टिव इंडेक्स ज्यादा होगा. रेड कम बेंड करता है, इसका रिफ्रैक्टिव इंडेक्स कम होगा. सो रिफ्रैक्टिव इंडेक्स डिपेंड्स ऑन वेवलेंथ आल्सो, राइट? सो व्हाट डिड वी से? एंगल ऑफ डेविएशन इंक्रीजेस विद द डिक्रीज इन वेवलेंथ. एंगल ऑफ डेविएशन किसका ज्यादा होगा? एंगल ऑफ डेविएशन विल बी मोर फॉर अ लाइट रे विच विल बेंड मोर. विच वन बेंड्स मोर? वॉयलेट, है ना? करेक्ट. सो एंगल ऑफ डेविएशन इंक्रीजेस विद द डिक्रीज इन वेवलेंथ. वेवलेंथ कम किसका? वॉयलेट का. बेंड कौन ज्यादा करेगा? वॉयलेट. एंगल ऑफ डेविएशन ज्यादा किसका होगा? वॉयलेट का. जस्ट कनेक्ट एवरीथिंग, कुछ नहीं है, राइट? इट इंक्रीजेस विद द इंक्रीज इन रिफ्रैक्टिव इंडेक्स. जो ज्यादा बेंड करेगा उसका रिफ्रैक्टिव इंडेक्स ज्यादा होगा, उसके लिए एंगल ऑफ डेविएशन ज्यादा होगा. इजी है ना? कुछ भी नहीं है इसमें. बहुत बढ़िया, राइट? चलो, नाउ आई विल गिव यू अ स्मॉल न्यूमेरिक आल्सो. वन इज red has minimum redf account. Red has minimum redf account. इसका मतलब red has minimum RE मतलब हो गया refractive index, DE मतलब हो गया डेविएशन और F मतलब हो गया फ्रीक्वेंसी। सोच के देखो रेड का क्या है सर, वेवलेंथ इज द मैक्सिमम इन दिस विजिबल स्पेक्ट्रम। वेवलेंथ ज्यादा है मतलब फ्रीक्वेंसी कम है, वेरी गुड। रेड बेंड कम करता है, राइट? रेड बेंड्स द लीस्ट, इट मींस इट हैज लेस रिफ्रैक्टिव इंडेक्स आल्सो, एंड व्हाटएवर बेंड्स द लीस्ट विल हैव लेस डेविएशन आल्सो। सो रेड हैज मिनिमम रिफ्रैक्टिव इंडेक्स, मिनिमम डेविएशन, मिनिमम फ्रीक्वेंसी, मिनिमम रेड एफ अकाउंट। ये हुआ एक तरीका, दिस इज वन वे ऑफ रिमेंबरिंग। आई विल गिव यू वन मोर न्यूमोनिक। रेड बेंड्स द लीस्ट, red bends the least and violet bends the most. Red bends the least, violet bends the most. As simple as that. And you know what? We'll keep adding on this poem more and more. Scattering पढ़ेंगे तो और बात करेंगे, right? Clear? Very good. So cause of deviation is fine, wavelength relation is fine, deviation is fine. All right. Now, because a white light is a mixture of the 7 colors, Vibgyor, when white light passes through a prism, every color bends differently. कुछ ज्यादा बेंड होते हैं, कुछ कम बेंड होते हैं, मींस द व्हाइट लाइट स्प्लिट्स इनटू 7 कलर्स। समझे? डिस्पर्जन क्यों हुआ? बिकॉज द बेंडिंग ऑफ ईच एंड एवरी कलर इज डिफरेंट। रेड का कम हो रहा है, वॉयलेट का ज्यादा हो रहा है, सो दैट्स व्हाई व्हाट विल हैपन, वॉयलेट नीचे निकल जाएगा, रेड ऊपर आ जाएगा। इट्स अ वेरी बेसिक क्वेश्चन, एग्जाम में आ जाता है, राइट? सो रेड इज अप एंड वॉयलेट इज इन द बॉटम। वेरी गुड। The splitting of white light into its constituent 7 colors on passing through a glass prism is what we call as dispersion. Disperse करना मतलब, disperse होना मतलब फैल जाना, है ना? फैला देना। तो हमने white light को फैला दिया उसके अलग अलग colors में। Dispersion, easy एकदम, right? Splitting of white light into constituent colors. Very good. Now, a question, फटाफट. Which of the following statements is/are, which means more than one can be correct, regarding the propagation of white light through a glass prism? कौन सा स्टेटमेंट, कौन से स्टेटमेंट सही है? ठीक है, लेट्स सी। फर्स्ट ऑप्शन, रेड लाइट मूव्स द फास्टेस्ट। सेकेंड ऑप्शन, वॉयलेट लाइट हैज द लीस्ट रिफ्रैक्टिव इंडेक्स। थर्ड ऑप्शन, इंडिगो लाइट हैज हायर रिफ्रैक्टिव इंडेक्स देन ब्लू लाइट। लास्ट ऑप्शन, येलो लाइट इज स्लोअर देन ग्रीन लाइट। कम ऑन, थिंक अबाउट इट. It's an easy question. I want the answers right now. Whoever is watching, tell me the answers in the comment section, in the live chat right now. Come on. And everybody else, like the video and subscribe to the channel. अब ध्यान से सुनो. Which is correct? White light is passing through a prism. Okay. It will split. Yes. It has 7 colors. Yes. पहला बोल रहा है red light moves the fastest. Red light has least frequency, yes. Red light has maximum wavelength. Red light bends the least. कौन bend कम करता है? Who bends the least? जिस पर refraction का effect कम हुआ. Whichever suffers the least refraction, least bending, will bend the least. Correct. Red bends the least means it moves fastest. Effect मतलब क्या होता है? इफेक्ट मतलब स्पीड स्लो होना। जिसका स्पीड स्लो कम होगा वो उतना कम बेंड होगा। एंड रेड इज बेंडिंग लीस्ट, मींस द इफेक्ट ऑफ रिफ्रैक्शन, दैट इज द चेंज और द डिक्रीज इन स्पीड, इज लीस्ट फॉर रेड। सो रेड इज द फास्टेस्ट इन ग्लास एंड यू कैन से वॉयलेट इज द स्लोएस्ट इन ग्लास, एटलीस्ट इन द विजिबल स्पेक्ट्रम। ठीक है, रेड लाइट मूव्स द फास्टेस्ट, सही है, एकदम ठीक। नेक्स्ट, वॉयलेट लाइट हैज द लीस्ट रिफ्रैक्टिव इंडेक्स। ना, हु बेंड्स द मोस्ट? Violet. इसका मतलब whoever is bending the most will have the highest refractive index. Least will be for red. So second is wrong. ये गलत है भाई. Third, indigo light has higher refractive index than blue light. Indigo, VIBGYOR. Indigo is here and blue is here. ठीक है? Indigo has higher refractive index than blue light. Now, we have learned this. As you move from red to violet, if you move, the refractive index will increase. Blue और violet में कौन ज्यादा बेंड करेगा? ब्लू और इंडिगो में कौन ज्यादा बेंड करेगा? जो उस तरफ होगा, बिकॉज violet bends the most and red bends the least. इंडिगो ज्यादा बेंड करेगा कंपेयर टू ब्लू. रिफ्रैक्टिव इंडेक्स किसके लिए ज्यादा होगा? इंडिगो के लिए कि ब्लू के लिए? Yes, indigo has higher refractive index than blue. You are right. Because as you move from red to violet, the refractive index increases. क्यों? क्योंकि bending बढ़ जाता है. जिसका bending ज़्यादा उसका refractive index ज़्यादा. एकदम आसान है ना? बहुत बढ़िया. So C is also fine. येलो लाइट इज स्लोअर देन ग्रीन लाइट. अच्छा देख लेते हैं. वेयर इज येलो? सर ये रहा येलो. वेयर इज ग्रीन? ये रहा ग्रीन. यू टेल मी which of them will have more speed? Red has the maximum speed, violet has the minimum speed. यानी कि जो इस तरफ होगा उसकी स्पीड ज्यादा होगी, जो उस तरफ होगा उसकी स्पीड कम होगी. येलो इधर है, राइट? येलो की स्पीड ज्यादा होगी किससे? ग्रीन से. ये बोल रहा है क्या? येलो इज स्लोअर देन ग्रीन लाइट. दिस इज नॉट करेक्ट यार. Yellow is supposed to be faster than green. क्यों? Because yellow is near to the red light and red is the fastest, है ना? So A and C become the correct answer. Nice question, good question. It has huge possibility to come in your board examinations. So please make sure that you understand this, okay? Next, let's move forward. Recombination of white light. अब सुनो, recombination of white light मतलब by one prism will split the white light. It will cause dispersion. Very good. Is there a way to recover the white light? दोबारा ले सकते हैं क्या? Yes. The spectrum can be recombined by passing through a prism kept inverted with respect to the first. ऐसे. First prism is splitting the light. Second prism is recombining. सोच के देखो, वो prism ऐसे रखा है, ये prism उल्टा रखा है, तो ये जो भी काम उसने किया था इसको उल्टा कर देगा, right? This prism is inverting everything that prism did. That prism did dispersion, this prism did recombination, and this combination as a whole will make sure that you get white light again. And if you think about it, ये जो combination है, glass lab के अंदर हमको splitting होता था. In glass lab, did we have dispersion? No, right? Yes, it's a good way to think about it. Recombination. How does it happen? Like that. It's a very common question which has been asked very frequently in board examinations. Okay? So focus. The spectrum can be recombined by passing it through a prism kept inverted with respect to the first one. That's true. This, my friend, is almost similar like refraction through a glass slab. क्यों? ये line और ये line parallel हो गए ना? And this is what used to happen in a glass slab. ये line और ये line, the two sides of the glass slab were parallel. ये भी तो parallelogram बन गया. This is also parallelogram. So this is effectively working like a glass slab. Glass slab के अंदर हमको dispersion नहीं मिलता था, right? So that's why. Understood? Clear? Very good. How to get the light back is clear. Prism is clear. Dispersion is clear. Wavelength is clear. Very good. Now, let me just summarize very quickly. क्या पढ़ा हमने dispersion में? Dispersion क्या होता है? It is the splitting of white light into 7 colors. Angle of deviation क्या होता है? The angle between the incident light and the emergent light is called angle of deviation. किस पे depend करेगा? पढ़ लिया हमने, right? Recombination कैसे होना चाहिए? ऐसे होना चाहिए. That's also fine. But during this whole thing, हमने बोला था कि ये prism hero है. यार कहानी तो बची हुई है ना? विलन तो अभी जिंदा है. हीरो कैसे हुआ? That's true. Because अब आएगा टाइम क्लाइमैक्स का. लेट्स कम बैक टू रेनबो. रेनबो में यू सी कलर्स. वी हैव जस्ट लर्न अबाउट डिस्पर्जन. यानी कि डिस्पर्जन में व्हाइट लाइट गेट्स स्प्लिट इनटू 7 कलर्स. रेनबो के अंदर वी हैव 7 कलर्स. ओके, डिस्पर्जन रेनबो कहीं ना कहीं एक साथ तो है, बट प्रिज्म का है यार. रेनबो इज इन द स्काई, प्रिज्म इज ऑन अर्थ. आसमान में कौन सा प्रिज्म आ गया? विच प्रिज्म डू वी हैव इन द स्काई? From where does the rainbow get its colors? You're right. There is not a prism which you are thinking. There is something which is acting like a prism. And what is that? Tell me. That is the raindrops. बारिश के बाद हमेशा इंद्रधनुष दिखता है, right? You see a rainbow after a rain. Why? Because we have droplets. And those are acting like prism. So, what happens? Listen to me very carefully. And एक गलती जो बहुत लोग करते हैं, तुम नहीं करोगे, बस ध्यान से सुनना. क्या? Dispersion of white light by prism, we know. Red is on top, violet is on bottom. Very good. By raindrop में क्या होता है? This is the shape of a raindrop. First, white light falls on the raindrop. ठीक है? क्या हो जाता है? It refracts, but every color will bend differently. True? Splitting हो जाएगा, right? So what is happening on this face? There is refraction also and there is dispersion also. Very good, right? On this face we have refraction also and dispersion also. Now light ray reaches this particular surface, है ना? Raindrop के अंदर. This particular surface, lot of people think it is total internal reflection. No, it is internal reflection. If you say internal reflection, fine. If you say partial internal reflection, fine. If you say total internal reflection, wrong. Total लिख दिया तो गलत हो जाएगा. TIR is something else. I have done a video on TIR. It's there on the channel. Go ahead, watch it out. But you know what? This reflection, it is not total. It is partial. इसका मतलब light rays ना बाहर जा रही हैं. They are going out, but some of them are getting reflected. और कहाँ सर देखने मिलता है ये? If you go to a lake and you can see your face ना, but sir that is a water surface. There should be refraction. That is partial reflection. वो भी partial reflection है, ये भी partial reflection है, ठीक है, fine. So this surface, it is, you can say internal reflection or partial internal reflection, but not total internal reflection. ये भी ठीक है, partial भी ठीक है, but total गलत है, ठीक है, fine. Now, light ray is coming back and on this surface, it just bends away from normal. क्यों? Coming from water to air, as simple as that. So there are three things happening. There is refraction happening, there is dispersion happening, and there is internal reflection happening or partial internal reflection happening, not total internal reflection. Very, very, very important. Fine. All right. तो इसकी वजह से क्या हुआ? अब in the sky, you have millions, you know, uncountable raindrops, I would say. ठीक है? You have so many raindrops. Each raindrop is doing the same phenomena, right? So, a rainbow is always formed when sun is behind you. क्यों? Light ray from the sun will go to the drop, get reflected, get refracted, get internally reflected, है ना? और इधर आएगी. सोच के देखो, आपकी आंखें यहां होनी चाहिए ना, right? So light should come from this side and then come back to your eyes. आपके पीछे से sunlight जाए, raindrop पे पड़े, disperse हो, reflect हो, and then come back to you. So rainbow is always formed in direction opposite to that of the sun. In a rainbow, red color is at the top and violet at the bottom. कैसे? ये देखो, ये जो red color है, this red color is coming to your eyes and this violet color is coming to your eyes. So for your eyes, नीचे हो गया violet, violet, violet and ऊपर हो गया red, 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 right? So that's why red is on top and violet is on bottom. Degrees की बात करें हम, degree, right now I'm not explaining, but you know what, I'll explain this to you separately, किस कभी और दिन, but not today, right? This is only for CBSE, core exam perspective, right? So, this is clear? Let's do a question on this. एक फटाफट बढ़िया question. और I'm thinking to give it a homework. This question is your homework. You have just understood rainbow formation. You have understood dispersion. You have understood prism. You have understood angle of deviation. You have understood how deviation depends on wavelength. White light, splitting, सब पढ़ लिया है. ये question आपका homework है. Tell me in the comment section, and whatever problem you have, let me know, because you know what, I'll reply back to you. And I hope you like this version of Concept Bytes, because this is time saving. I want to make sure your time is saved. This particular video you can use anytime for revision. Welcome to Concept Bytes. Subscribe if you believe whatever we are doing is helpful to you. Subscribe करो, बगल में bell icon है, उसको press कर दो, and like the video if you think this was helpful. Rest, we'll meet again next session. Take care. Bye bye.